Let's try two examples where we're going to solve the differential equation. We're going to have a c value, but then we are given the initial value of 0, 10 to figure out what the constant is so we can actually get the function instead of just leaving it as it is. So, anyhow, we have, for our first example, dy dt is equal to negative 3/4 square root of t. So we're going to move the dt over here. So we're going to have dy is equal to negative 3/4 square root t dt. And now we can integrate both sides. And this isn't too bad. We're going to get y plus c1 is equal to negative 3/4. When I integrate this, I'm going to move this as a power of 1/2. I'm going to move it to 3/2. I'm going to multiply by 2/3, which is the reciprocal of that. And then t to the 3/2 plus c2. All right, I'm going to combine these, and I'm also going to combine the two constants over to one side. So I'm going to have y equals negative. 3's cancel out, 2 over 4 is negative 1/2, t to the 3/2 power plus c. Given the initial condition of 0, 10, I'm going to plug that in and get a value for c. So let's do that over here. 10 for y is equal to negative 1/2, 0 to the 3/2 power plus c. Well, 0 to the 3/2 power is still just 0, and 0 times negative 1/2 is still just 0, so that all just goes away. So c is equal to 10. So our actual function, we have y equals, let's see, negative 1/2 t to the 3/2 plus 10. Not so bad. I do have a second example. It's a little bit more challenging, but of course we can figure it out. It's no big deal. All right, so let's just slide this up. And we're still going to have that initial value of 0, 10. dy dt is equal to 3/4 y. So the only thing that's difficult about this one is the y is on the wrong side. So we actually have to divide away the y, multiply the dt over here. So we have to do a lot of moving around with this one. So this is going to work out to be, once we move everything out, 1 over y dy on the left is equal to 3/4 dt. Integrate both sides, and we're going to get 1 over y. This is going to be ln of the absolute value of y plus c1 is equal to 3/4 x plus c2. Just like before, I'm going to move the two constants to the same side. And remember, they're just constants, so when they combine, they just combine to make a new constant. You don't have to do anything special with them. Anyhow, let's plug in our initial value of 0, 10. So ln of 10 is equal to 3/4 times 0 plus c. Well, 3/4 times 0 is just 0, so c is definitely equal to the ln of 10. What is the ln of 10? It's about equal to 2.3026. Oops, 026. So our actual function here would be ln of y is equal to 3/4 x plus 2.3026. All right, now if we wanted to actually put this into y equals form because we wanted to treat it like a function, we could actually do that. It would get a little bit more complex, but if we want to have it in function notation, we would have to do that. And the only reason I'm saying that is because our initial thing said y is equal to f of t, so we're looking for a function. So I would just solve for y, and that's going to give me y equals e to the 3 over 4 x plus 2.3026. Now we can write it like this, but actually e to the 2.3026, let's think about that. If ln of 10 was equal to that, then e to this should equal 10. So we could actually rewrite this using some of our properties we know. And once again, not necessary. As we've discussed in class, there's different forms that are all acceptable. So this could be rewritten as y equals e to the 3/4 x plus, times e to the 2.3026. Because when the exponent is added, we can separate it into two powers combined with multiplication. E to this power should equal 10, so we can actually have y equals 10 e to the 3/4 x. So either of these would be completely acceptable, as well as the first one. You know, whichever one you end with is the one that, we'll stick with. So, of course, when you look in the back of the book, you're going to see one of these versions. You won't see all of them. So hopefully you can find one of them. The two examples I'm going to give you from here are on page 366, numbers 17 and 19. Try them out and send them in. If you have any questions, let me know.